Hey guys, just want to touch on one thing today as I've seen an example situation and I want to explain how to do this particular situation. So let me show you what I mean. So at the end of our math class, we went over how to convert infusion rates when given dosages. So meaning how to get to, say, milliliters per hour when we're given, say, milligrams per hour or micrograms per minute or something along those lines. And from there, we're asked to calculate that infusion rate. So that's what I mean. We're asked to calculate the infusion when we're given some type of dosage. So if we're given anything like milligrams, micrograms, units, anything like this, these are all dosages, which tells us how much medication the patient needs. But we need to know what that equates to in fluid, because that medication is going to come in some type of fluid, and I want to see what that is. And again, fluid typically is administered over, a long period of time, so we usually have to set that rate as milliliters per hour. So sometimes if that dosage is given to us as per hour, we don't really need to think of anything there because it's already in the unit I want it to be in. And then if it is in minutes, we do have to incorporate how to switch that into hours. So let me give you an example of what we did with one of those. And I want to show you the situation I'm referring to. So if let's say we have a problem where I've ordered a patient to take 25 micrograms a minute. And let's say that medication, the supply, on the label, we know how much, medication the patient needs. But again, if I'm trying to eventually get to milliliters per hour, I need to know what it comes per how many milliliters. So how much medication is in each, that amount of liquid. So the supply, let's say, says that it comes as 50 milligrams in 500 milliliters of D5W, again, which is just 5% dextrose water. That's simply just what's in the IV bag or what the solution that it's been diluted into. But so this is what we can do. So from this medication here, from this order, because I know how much medicine they need, and then I know how much is diluted in this liquid, from there I should be able to figure out what they can, set the infusion pump for. So what we did, what we talked about is first thing we need to think about is that, the ordered dose is micrograms per minute. Again, remember I showed you guys, I said, well, if we're trying to go from micrograms per minute to milliliters per hour, in a situation like this, there's really kind of two things that need to be done here. One, I need to get it from minutes into hours. We know that there are 60 minutes in an hour. So in that case, what we're going to end up doing is we're going to multiply it by 60. Because I know what they're given per minute. So if they're getting 25 micrograms every single minute, they're going to get another 25 micrograms in the next minute, another 25 in the next minute. They're going to end up doing that 60 times in an hour. So by multiplying it by 60, we can figure out what that would be per hour. And then anytime we're trying to go from a dosage and we're trying to convert it to that liquid medication there, we then are going to have to incorporate the dosage formula. The dosage formula that we know, hopefully we've done it many, many times in math, that D over H times Q formula. So again, what happens, and I mentioned to you all in class too, it doesn't matter what order you go in. You can do either one of these first, and as long as you do both of them, you'll get the right answer. But I was in the habit of just going ahead and getting that into per hour first. So let me actually just remove some of this here, if it'll let me. So go back down here. So again, if it's 25 micrograms per minute, then what we can do is multiply that by 60 to see what that would be per hour. So when I do that, 25 times 60 gives me 1,500. So that means this patient needs 1,500 micrograms every hour. So we've already taken care of that part of our answer. Now we just need to use the dosage formula to get it into milliliters per hour. So here's what our ordered dose is right now. 1,500 milligrams. If we plug that into the dosage, it's micrograms, not milligrams. Silly me. Okay, 1,500 micrograms. If we plug that into the dosage calculation right now, our supply is 50 milligrams per 500 milliliters. Remember, from what we've talked about so many times with our dosage formula, I cannot continue this problem. I cannot go ahead and take 1,500 divided by 50 because, remember, D and H in our dosage calculation needs to be the same unit. As long as you get them to the same unit, it doesn't matter which one you convert. You could convert that top number, the 1,500, into milligrams, and then therefore they'd both be in milligrams, and you're good. Or you could do the opposite. You can convert the 50 milligrams into micrograms, and then they'd both be in micrograms. It does not matter. I'm going to go ahead and just, because I already wrote that down, I'm going to convert that 1,500 micrograms into milligrams. Remember, using our metrics, micro to milli is, depending on the method you're using, is 3 places to the left on our metric chart. Or if you're using the stair-step method, that's up a step, so therefore we would divide by 1,000. Either way, 1,500 micrograms is 1.5 milligrams. So now that they're the same, now I can go ahead and divide this out. So I get 1.5 divided by 50, and then I'm going to take that answer and multiply it by 500, which gives me an answer of 15 milliliters. Remember what we did there when we used the dosage formula. Since they're the same, they cancel out, leaving me with the last unit that's in this problem here, milliliters. And again, we had already converted it to per hour, so therefore our answer is per hour. So we actually did that at the end of our math class, so you guys should have a little bit of experience with that. The situation that I'm referring to here that I've seen come up recently is what happens if we're given this number and not this one, not the order dose of 25 micrograms per minute. What if instead I'm told we know the infusion rate? Can I, from that, then calculate what's been ordered, or how many milligrams that patient is getting every minute? Absolutely. What we're going to be able to do is the reverse of this. So I'm going to use the exact same numbers to show you how we can do that. That if I start with 15 milliliters per hour, I'm going to show you how we can get to that 25. So let me go to a new slide here. And just again, here's what's happening. If I'm told that a patient is being given 15 milliliters per hour of a certain medication, I know that that medication supply, again, same as, excuse me, I'm sorry, the supply is 50 milligrams in, oh, I want to make sure that I actually did that right. Was it 50? Yeah, 50 milligrams in 500 milliliters of D5W. And again, we are now trying to see, well, what are they getting in micrograms per minute? So guys, this is the exact reverse of what we did a second ago. So from here, what's happening is we're given the infusion rate. So I need to get to the dosage, is what I'm trying to figure out. So again, 2 things need to take place. We're still going to incorporate that dosage formula, but instead of using D over H times Q, we're kind of reversing that problem since we're given the answer, and I'm trying to find D. So I'll show you how we can do that. And then the opposite here, since we're going from hours to minutes, we're going to end up dividing by 60. But I'm doing the exact backwards thing that I did previously, so I'm going to show you what I mean by that. So if we have 15 milliliters per hour, a way that you can kind of think about that, since we're so used to the dosage formula, we're missing D in this problem. We're missing that dosage that's been ordered. We do, however, have our H and our Q, and again, we have the answer, milliliters per hour. So what we can do to get to X is just do the opposite of what we do in a dosage formula. So if I kind of think, when I say opposite, I'm kind of reversing this here. What I'm going to do, since my dosage formula is typically, this is how you solve for X in these algebra-based problems, is you do the opposite of what's being done. So like with that 15, if I divide it by 500, again, the opposite of that, and then what I'm going to do is I'm going to multiply it by 50, because it's the opposite of what's happening. This is how we're getting x by itself for anybody that's familiar with pre-algebra without having to kind of go into pre-algebra. That's what we're doing, is we're doing, like I said, the reverse of what we've done before, because we're trying to get the reverse answer. We're trying to get that dosage. So what I can do, doing the opposite there, if I take that 15, and again, first, I'm going to, again, since the problem says we typically multiply by 500, this time I'm going to divide by 500, which gives me 0.03. Then I'm going to take that answer and multiply it by 50. So the second step, again, is to do the opposite of this, which would be to multiply by 50, which gives me 1.5. Now remember, what is that 1.5? Because our dose on hand is milligrams, what we just calculated is also milligrams. Because again, remember, we always want D and H to be the same unit. So therefore, that's what we've just calculated, is D, but as the same unit as H. So this means we know, and again, since the supply is per hour, we know what that is per hour. So we've already got it to it by using this reverse of this dosage calculation. We were able to figure out that they have now, that we know that they're getting 1.5 milligrams every hour. Again, we're trying to calculate micrograms, so let's use our metrics. Let's use what we know about metrics. If 1.5 milligrams is what they're getting every hour, what is that in micrograms? Well, using our metric chart, milli to micro, if we're converting that to micrograms, this is what we're trying to do, milli to micro. Again, that's 3 places to the right on our metric chart. So moving our decimal 3 places to the right. Or milli to micro using the stairs. For those of you guys who use the stair step method, is down 1 step. So we'd multiply by 1,000. That would be 1,500 micrograms. So we know this person is getting 1,500 micrograms every hour. Again, the question said, what are they getting every minute? So again, if that's what they're getting every single hour, that's the amount that they're getting in that full hour. But I want to know what they're getting each minute. So remember the reverse of what we did before. If they're getting this in an entire hour, there's 60 minutes in an hour. So we would simply divide this by 60. 1,500 divided by 60 means that this person is getting, and I'm just going to write the answer right up here where I have some space, 25 micrograms every minute. So that's what we would do if you have a situation like that, where if you're ever given the infusion rate, but you need to figure out what that is in a dosage, then you just simply need to do the reverse of what we're used to doing. And that kind of helps to think that's how we get there, using that supply versus the, we could figure out to put that into a formula, that it would be the infusion rate divided by the quantity, multiply by the dose on hand, and then so I guess that would be infusion, you're dividing it by Q, multiplying it by H to figure out that D. If that helps, that's the reverse of what we were just doing. We just put that in, if you wanted to put it into a formula, that makes it easier. That's what we ended up doing, instead of using the D over H times Q formula. But that might be kind of confusing. So again, that's the way that I always think about it, is that if I'm really given the answer, I simply just need to think, well, let's think backwards. Let's do what we did before, but just do the total opposite. All right, guys, so I hope that helps if you guys ever come across a situation like that, and you guys know if you ever need more help with problems like these, I'd be glad to help.